This time we will discuss about the integral that involves trigonometric functions. So we have here the following formula: integral of cosine u du, that is equivalent to sine u plus c. Integral of sine u du equals negative cosine u plus c. The integral of cotangent u du equals ln of sine u plus c. The integral of tangent u du equals ln of secant u plus c, or integral of tangent u du equals negative ln of the absolute value of cosine u plus c. And then the integral of cosecant u du equals ln of cosecant u minus cotangent u plus c, and the integral of secant u equals ln of secant u plus tangent u plus c. So take note, when we take the integral of these trigonometric functions, this is just an antiderivative of our trigonometric functions. For example, the derivative of sine u equals cosine u du. Also, the derivative of the derivative of cosine u equals negative sine u du. And then if we have here the derivative of tangent u equals secant squared u du. Therefore, the integral of secant squared u du equals tangent u plus c. Also, the derivative of secant u equals secant u tangent u du. And then its integral of secant u tangent u du equals secant u plus c. So they are just a reverse, or these are just the antiderivative, okay, of our trigonometric functions. So these are the different formulas that of integral that involves trigonometric functions. Now, how do we use this formula? So we will have this one as our example. We have, let's say, example number 1. So example number 1, that is the integral of sine, let's say, 5x dx. So if you have noticed this one, we can make use of this formula, integral of sine u du. So if we will use this formula, integral of sine u du, then we have to check our u. So integral of sine u du, if we use this formula again, let us check our u, which is equivalent to, for this case, that is 5x, and then the derivative of u equals derivative of 5x equals 5 dx. So for this case, you have here du equals 5 dx. If you have observed this one, this is 5 dx, and then this one is dx. So the only difference is this presence of number 5. This one is, there's no number 5. So that's the only difference when we apply our sine u. This one is sine u du. Supposed to be this one is sine u du. So for this case, we can apply this formula sine u du because the difference is only 5. So we have, I will rewrite this one. Sine of 5x, instead of writing dx, we will write here as our du equivalent to 5 dx. And if we write here 5 dx, then we will write the reciprocal of 5, which is 1 over 5. So that this one is equivalent to 1 over 5 times the integral of sine 5x. So that will serve as our sine u, and then this 5 dx is our du, so du. Therefore, this one is 1 over 5 integral of sine u du, that is equivalent to negative cosine u plus c. So negative of cosine of our u, which is 5x, plus c. And if we multiply this negative sign to 1/5, that is negative 1 over 5 cosine of 5x plus c. This is our final answer for example number 1. Now this time we will proceed to example number 2. So for example number 2, we have the integral of x cosine of x squared dx. Now if you have noticed here, cosine x squared, this one is similar to this formula cosine u du. So if we apply this formula, integral of cosine u du, then we will rewrite this one as the integral of cosine of x squared times x dx. This will be our target du, x dx. Okay, I am just rearranging this x. So we have here x dx, cosine x squared, and then this one x dx, this one is x dx. So this will be our target du. So if we will use this formula again, we will check our u. Our u is equivalent to cosine x squared, so cosine of u, therefore u equals x squared, and then its derivative of x squared equals 2x dx. So if you have noticed, this is x dx, and then this one is 2x dx. So again, the difference is the presence of number 2. Therefore, we have here, okay, I will rewrite our problem, cosine of x squared, and then instead of writing x dx, I will write our du, which is 2x dx. So I have here number 2, and then multiplying the reciprocal of 2, that is 1/2. Okay, so this is now our cosine of u, and then this one is our du. Okay, so this is 1/2. Therefore, our final answer is 1/2 integral of cosine u du, that is equivalent to sine u. So we have here sine of our u, which is x squared, sine of u plus c. This is our final answer. Next example, number 3, we have here, let's say secant 3x, secant of 3x, and then secant of 3x plus tangent of 3x. We have this one dx. Okay, so if we have this one, then we will try to distribute secant 3x to the other trigonometric functions. So we have, because there's no direct integral for this one, so secant 3x times secant 3x, that is equivalent to secant squared 3x plus secant 3x plus tangent 3x equals secant, okay, I will have this one, I will change this one, I will distribute dx plus integral of secant 3x tangent of 3x dx. Okay, we distribute the sine 3x to this one, and then multiply to tangent 3x. So the result is secant 3x tangent 3x. Now, if you have noticed this one, secant squared 3x, this is similar to this formula, secant squared u du tangent u. So we have to check our u. For this case, our u equals 3x, and then our du equals 3 dx. Therefore, this formula is applicable for this particular problem. Now, how about the other problem, secant 3x tangent 3x? This one is the available formula, secant u tangent u du. Again, our u equals 3x, and then the derivative of 3x equals 3 dx. So this is dx again, so the difference here is 3. So we must have, or we must put a multiplier of, which is the reciprocal of 3. Okay, rewriting this one, you have here, since this is 3, I will write its in reciprocal 1/3 integral of secant squared 3x times 3 dx. This is our du. And then this one also, we have a multiplier of 1/3, the integral of secant 3x tangent 3x 3 dx. so that when we integrate this one, the result is 1/3, and then this secant squared u, that is tangent u. So tangent of our u here is 3x, and then plus 1/3. This one, the integral of secant u tangent u equals secant u, that is secant of 3x plus c. Okay, so we're using here secant u tangent u and then secant squared u du for this particular problem. Okay, so we will proceed to example number 4. Now for example number 4, we have here the integral of 2 dx over secant of 4x plus 2. Now if you have noticed here, this is 2 over secant. Now this is supposed to be 1 over secant u, that is equivalent to cosine u. I mean, in other words, cosine u is equivalent to 1 over secant u. This is based in our trigonometric functions. Also, take note also that 1 over cosecant u equals sine u. Also, we have 1 over, sorry for that, we have here 1 over tangent u equals cotangent of u. So these are just the inverse of some trigonometric functions or some identities of trigonometric functions. So going back to this one, we will write it as, okay, so we have these 2, I will write first 2, and then 1 over secant equals cosine. Okay, I will write it here. We have 2 integral of cosine of 4x plus 2 dx. Take note, 1 over secant equals cosine. And then for this case, we will now be using this formula, integral of cosine u du, which is equivalent to sine u plus c. So we have to identify again what will be our u. For this case, our u equals 4x plus 2, and then the derivative of u equals 4 dx. Again, this is dx, so we have here 4, then we will have our multiplier of 1 over 4, which is the reciprocal of 4. So we have 2 times the reciprocal of 4, which is 1/4, and then integral of cosine of our u, let's say here 4x plus 2. Instead of writing dx, then we have here 4 dx, because we already write our this 1/4, the reciprocal of 4. So that when we integrate this one, this is 2 over 4, that is 1/2. And then integral of cosine equals sine u. So we have here sine of 4x plus 2 plus c. So that is our final answer. Example number 5. That is the integral of sine squared of x dx. Okay, if you have noticed, there is no direct integral of sine squared x. This one is integral of sine u du. So we do not have any, we do not have any direct integral or integration of sine squared x. Instead, we will change this sine squared x to its equivalent identities. So that is equivalent to, this one sine squared x is equivalent to 1/2 1 minus cosine, and then this is x, so double angle formula, that is 2x times 2 dx. Okay, So take note, sine squared x, remember our half angle formula. You have here sine squared u, that is equivalent to 1/2 of 1 minus cosine times twice your angle here u, so 2u. And then also remember also that cosine squared u equals 1/2 1 plus cosine 2u. That means you have to double your angle here, so double angle formula. So this is just an equivalent of sine squared and cosine squared u. So that when we integrate this one, of course we will distribute this integral sign with dx to 1, so equivalent to 1/2 integral of dx. So integral of 1, so that is 1 dx minus 1/2 times this one, so 1/2 integral of cosine of 2x dx. So that this one cosine u, let u equals 2x du equals 2 dx. So we must have another multiplier here, which is 1/2. So that we have 1/2 integral of dx minus 1/2, and then the reciprocal of 2 is 1/2 integral of cosine 2x 2 dx. Therefore, our final answer here is 1/2 integral of dx equals x minus 1/4, and then integral of cosine equals sine u. So we have here sine of our u, which is 2x plus c. This is our final answer. Next example, we have the integral number 6, integral of, let's say, cotangent x cosecant squared x dx. Now, cotangent, there is no direct integral for this problem, cotangent x cosecant squared x. If we use cotangent x, this one, take note, cotangent u du, our u here is x, so we have here our target du, which is cosecant squared x. Therefore we cannot apply directly cotangent u. Instead, we will make use of another formula. Out from this integral that involves trigonometric, we will make use of u to the n. The integral of u to the n du. For this case, our u is cotangent x. So we will write here cotangent x as our u, and then our target du is cosecant squared x dx. So that when we check our u, which is equivalent to cotangent u, cotangent x, then its derivative of u, derivative of cotangent x equals negative cosecant squared x dx. So this is now similar. You have your cotangent squared x and then cotangent squared x dx. The only difference is the sign. So this time this formula u to the n is now applicable because the only difference is the sign. So we will now write the sign, which is negative, and then integral of cotangent u, that is cotangent x, raised to 1, and then instead of writing cosecant squared, we will write the negative sign of cosecant squared x dx. That means integral of u to the n du, which is then equivalent to negative cotangent squared x over 2. That means cotangent x raised to 1 plus 1, that is raised to 2 over 2. That is our solution when we have our integral of u to the n du equals un plus 1 over n plus 1. So for this case, cotangent x of n plus 1, that is 1 plus 1, equivalent to 2 over 2 plus c. So that is example number 6. about number 7, we will have another example. Let's say the integral of cosine x 3x dx over, let's say, the square root of 3 plus, let's say 3 plus sine of 3x. Okay. Again, this formula, this problem, you cannot solve directly this problem using all of this formula. So instead, we will think of another formula which is applicable for this particular problem. So I think we have to use u to the n, the integral of u to the n du. So if we use this formula, we will rewrite this one in terms of u to the n du. So instead of writing this one, then we will write, let's say, 3 plus sine of 3x. We raise this up, we raise up our denominator and make it as our denominator, so negative 1/2, and then this one is cosine of 3x dx. So if you have noticed, this will be our u and du, target du. So we will check if this target du, okay, will be equivalent to our test. So let's say u equals 3 plus sine of 3x, and then the derivative of u, that is derivative of sine, equals cosine 3x. Cosine 3x, and the derivative of 3x equals 3 dx. So this can be rewrite as our du equals 3. I will write first this number and then cosine of 3x dx. So if you have noticed this one, this is cosine 3x dx, and then this one is 3 cosine 3x dx. Again, the difference is this number 3. Therefore, this u to the n du is applicable for this particular problem. So we will write this one. We will rewrite this one. So this is 3, so I will write its reciprocal 1/3, and then 3 plus sine of 3x raised to negative 1, 3 cosine of 3x dx. So take note, this one is our u to the n du, which is then equivalent to 1/3 u to the n du. We have 3 plus sine of 3x, and then negative 1/2 plus 1, that is 1/2 over 1/2 plus c, our final answer, 2/3. And then we have here 3 plus sine of 3x, and then we have 1/2 plus c. This is our final answer. Next example, last example, we have the integral of, so example number 8, cotangent squared. Let's say cotangent squared 4x dx. If you have noticed here, there is no cotangent squared from our formula. Instead, we will transform this one to another identities. Take note that cotangent squared u, okay, so let's say cotangent squared u, or cotangent squared x. This cotangent squared x equals cosecant squared x minus 1. Also, tangent squared x is equivalent to secant squared x minus 1. So these are just some of the identities that we have to recall. So integral of cotangent squared 4x dx, that is equivalent to cosecant squared x minus 1. So we will rewrite this one as cosecant squared x minus 1 dx. and then we will distribute our integration. We have cosecant squared x dx minus integral of dx. By this time, we have now, we have the integral, we have the integral of cosecant squared. We have this one, integral of secant squared u, which is equivalent to tangent u plus c. I will erase this one. Okay, now we have let u, for this one, let u equals x, and then du is equivalent to dx. So if you have observed, we usually check our u before we take, and then we take the derivative of u before we use our formula. So for this case, you have the integral of cosecant squared u, which is equivalent to negative cotangent u. That is equivalent to negative cotangent of u, which is equivalent to x, minus the integral of dx equals x, and then plus c. So this will be our final answer.